cloud. So the concept of local variables is going to be what happens when we use functions. Okay. So for example, we're going to define, so right now, every program we have should have comments, of course. You need a def main every time. Okay. We'll have something there at least. And then we want to have where we call main is the last line of our program. Okay. So let's say we have a function here where we're going to set up some variable. Okay. X equals 10. You have another function called f1. Say has y equal to 12. Okay. If I print x here, I'm going to be fine. And if I print y down here, I'm going to be fine. Okay, so I didn't have to actually call it for it to work. If one doesn't matter. I'm just making it up. Okay, so this both works, right? So here I'm able to print out the x. Here I'm able to print out the y. Okay. So the trouble comes in if I try to print out y up here and x down here. That's going to fail. In fact, it's going to fail first on the y, but it's going to eventually fail on the x as well. That's because it's concept of local variables. Okay. So let's make sure we understand how this is going to execute as far as the lines go. Okay. So what's the first line that's going to execute of this program? 16. What's going to happen next? Well, it's going to go to 3, then go to 4, then go to 5, then go to 6. Then where's it going to go? Going to jump to 9, then 10, then 11, jump back to 7, basically. The 7th blank, so it's going to end, right? Okay. So the reason we're having trouble here is that functions that are declared inside of a function, sorry, variables declared inside of a function are local to that function. So from a computer science sense, we would only say that they have scope in that function. Okay. So we can therefore up here get to x because x has a value. But down here we can only get to y because y has a value. Okay. So let's take a look at what this means as far as the memory map goes. Will eventually pop up. So the basic idea being that when you call your program, whatever it's called, the operating system is going to give you a big block of the system memory. Okay, that's going to vary based on which operating system it is. We have a main function. When that main function hits, so at that very last line of that program, the main function is going to get its own chunk of that memory. Okay? And it could be that the program starts running, maybe down here is where the base of the program is. But once we hit main, the main is going to be up here. Okay? So everything main does is going to be there. We also have an F1 when that's called. So in our main, X is going to be a label that points to whatever we put next. I don't remember the value. Okay. When we start the F1 function, it's going to have its own memory space that's somewhere different. And it's going to have a Y, so 12 in it. Okay. So depending on where you are, it's all you can see is what is local to you, okay? So if the program is, before it starts down here, it didn't see any variables at all. If we're inside of main, we can see the x. That's the only variable we can see. If we are inside of here instead, all we can see are the y, okay? It can get more complicated if we decide to define x again down here. Okay? So if we decide that we want x to be in both places, okay? These are clearly not the same x, right? One's in one spot, one's in another. So the practical import of that in our code I do x here and print x. Okay. These are different x's. So if I print x again after I've hit the function, if they were the same variable, then the before and after would have different values. Epsilon, go away. Epsilon will not go away. The before value, after value. Run this. We see that before the function x is 10, but after the function it's still 10. Okay? And that means that whatever happens outside of the function doesn't change that. Okay? And again, the reason being, think of the diagram I just did. Okay? That the x that is defined in main is in main's memory area. The x that's defined in F1 is in F1's memory area. And we have some saggy noses. Everybody pull up your noses. All right. Everybody else okay? Okay. Don't want saggy noses. Okay. So you have to keep that in mind when you're running your programs. Okay. Again, that's the scope. Are there questions about that so far? Okay, they're going to point to totally separate variables. So like we did yesterday in lab, we have the ability to send in information to our functions. Okay, so if I wanted the user to enter a name up here, okay, what I wanted to do this one. The name is equal to input, enter name. Okay, and down here, I want to be able to print happy birthday name. Okay. So if you did this in essence in your programs yesterday, okay, is this going to work? Her name. Oh, I didn't do anything. Oh, I didn't call it for him. You have to call a function for it to work or not work. Okay, it does not work. It doesn't work because name's not defined. Okay, so name lives in the main memory neighborhood, and we're now in the F1 memory neighborhood, so it doesn't work. Okay, what we can do, we can change our function to where it's going to accept an outside parameter. Okay. So I can call this name if I want, that's okay. And call that name there. Okay. If I run this now, this should work. Okay. So when I do this, what this is doing really, it's saying that name local to me is equal to the name passed in. Okay. So it doesn't really do that. You don't have to comment that. That's really what's happening. Okay. In fact, we can use a different variable if you want. So in this case, the n that is in scope in F1 is going to be whatever name value had when it came in, when that's called. change this. Okay, so if you want to have a variable or have information be sent from the main program into a sub function, then you have to specifically send it via this way. Okay. We call that passing an argument. Okay. We also refer to those as the parameters we're sending. Okay. If you try to call the function without sending a parameter, it's going to complain. If I do that, your name, it's going to give you an error. Okay. It's going to give us an error because, as it says here, that the F1 had a required positional argument that it needed to fill in here. This was required, so this didn't happen. Okay. But remember that functions have no side effects, which means that even if I call them the same thing, okay, I say happy birthday, but I'm going to say now name is equal to Rex. Okay. If I print name back up here after the function call, oh, I better change that. Okay. We see that the change to Rex did not happen. Okay. But again, if I print name inside the function down here, okay, we see that name has the value Rex inside of that function. So for that reason, sometimes if this confuses you and you don't know which name is which and it's going to be a problem for you, sometimes I will do this. Instead of doing name, I'll do something different. Let's make this an N. Then it's clear in my head that the N here, while originally equal to whatever I entered from main, that they're not the same thing. And the book has some diagrams to help you do that. Okay. Other questions about that? Okay. Let's do an example the book has on, this is in the spotlight on page 228. Okay, this one we want to have the user enter the number of cups, convert cups to ounces, display the results. Okay. So 228. Okay, so I need to get number of cups first. Okay, let's think about that. Okay. Nearly everything we're going to do is going to be inside of the main function or some other function. You want your functions to be as generic as possible. You don't want your conversion function to be asking for input. So ask for input in the main. Do printing typically in the main. Okay. I'm going to do this. Cups is equal to int input number of cups. Okay. Now I can go ahead and create a call to a function I'm going to create called cups to ounces, which is going to take that cups. So I have to define cups to ounces. It's going to take the number of cups coming in. Okay. Again, this cup and that cup are not the same cups. Okay, two different cups. Okay. What I would normally do, but we're not there yet. This would more correctly be a returning function. We just return the amount of ounces and do whatever. We can't do that yet, so we have to print out, which violates one of our rules, but we'll get past it. Okay. So here I can just say that ounces is equal to cups that gets passed in times 8. There are 8 ounces in a cup. I can print. That converts to ounces. Okay. This should work. 1 cup doesn't work. Oh. Didn't spell it correctly. 1 cup converts to 8 ounces. Okay. Are we done? No, still have. Bill, no. Okay. Are we done? Since I'm asking you, are we done? Probably means we're not done. What do we do for a real program in this class? Input validation. Probably wins the prize. Okay. We're not going to do it because we've done it before. But in general, cups shouldn't be negative. Cups probably shouldn't be 1 million. There's probably some limit to that. Okay. But yeah, you want to do validation. We're not going to do that. Okay. So you guys understand what's going on so far? Any questions about what's happening so far? Okay. You're not limited to how many things that you can send. You can pass multiple arguments. So for example, I could create a function. That. Let's say I'm going to create a function called add. It's going to take an x, it's going to take a y. Then it's going to print out the sum is x plus y. That's all it's going to do. Okay. So again, from up here, I can ask for values. I can just type them in directly. Or I can just call add a couple of times. I can say add 4, 5. Add 3, 9. Whatever you want. So run this. Okay, it'll work correctly. Right? It's 9, which is 12. When there are multiple arguments, then whatever we send as the first parameter here gets assigned here. So the first time we run this, what we're in essence saying is x is equal to 4, and we're saying that y is equal to 5. Okay. The next time we run it, x is equal to 3, and y is equal to 9. Okay. Now note that functions between call and call have no idea what's happening. They don't maintain any information. Okay. So we're in the general main memory of the program when we're here, when we're here. Now we're in the main area. So this time we're going to create an add memory area, print out that result. That goes away. We're back to main. Create that again. Okay, so every time it's going to be different. Okay, questions about that? So if I were going to instead set some variables here, x being 4, y being 5, for example, and then say add x, y. Okay, so x here is going to take on the value of x up there, okay, and y takes on the value of y. It's going to work, but the x here, or it's not the x there. So if I make changes, if I would then say down here that x is equal to 100, when I get back to here, x is not 100, right? It doesn't flow back. Okay. What gets more confusing what is this going to print out? We got the value of x. What's the value of x at that point? How many say 4? How many say 5? It's 5. Because I'm saying, again, it doesn't care about anything. It doesn't know what anything is. It says the first thing you're sending me, I'm going to call Y. What's the first thing you're sending? Okay. So in essence, this is saying Y is equal to 4. The second thing is X. So we're going to call X is equal to 5. Okay. So Y should print out as 5. It does. Okay. Is this a good idea? This good code? No, bad code. Don't do that. Okay. But it just shows that the order matters. Okay. And again, whatever changes I make to here are not reflected back in the main program. Page 233, yes.
So the order just pop it down.
With that?
The order is just pop it down.
Yeah, the order, whatever order it is, it's going to give the same order. Okay. So if you're going to keep the same variable names, keep them in the same order, it's going to be confusing. Or whatever you're going to do. Just make sure when you have multiple ones, you do. Okay. And if it wants 2, you can't send 1, you can't send 0, you can't send 3. It wants 2 parameters. That's all we have to do. Okay. There's some stuff on page 233 on keyword arguments. It's a way to avoid that. I don't like that. I think it's confusing. I think you don't need to know that now. If you want to read it, read it. If you want to use it, use it. But I'm not going to ask you about it. We're just going to pretend it doesn't exist. Okay? Try to keep it straightforward. So the next question becomes, what happens? Does everything have to be inside of a function? Well, it didn't before, right? And it still doesn't. So I can do whatever I want here. I can print out what? Okay. So now the order of execution here starts with 3. 3 will be the first thing to execute. And the next thing will be 17 and so forth. Okay. But we also have the ability to set up variables here. Let's say we're going to set up a Z equal to 23 right there. Okay. So the Z is not held in any function. So the Z was defined in that great big memory space that the program has. And that gives it what we would say is global scope, which means if I print Z here, I'm going to get, it's going to be okay. If I print Z down here, it's also going to be okay. Run that and see that it's not going to give me any trouble. It correctly prints those values. Okay. So we have visibility everywhere. But there's a problem here. If I were to say Z is equal to 111 here, okay, this is not a reassignment of a variable. I can't get to the variable out there, right? I'm inside of main. I have no access outside of main, except that I can see the value of Z. I can use it in the calculation, do whatever I want. Okay. If I try to change it, it should give us an error, but it doesn't. Instead, it creates its own local variable called Z. Okay. So now the Z that's highlighted is not the Z at the top, and it's not the Z down here. And we'll see that in that that's going to be, was that the first time it prints a Z? Yeah. No, this we go. Oh no, it goes to add first. So the first time it prints Z is down here. Okay, but that messed me up. That didn't help my example. It did. We'll go up here. Before the add, let me print. So this is in main. I'm printing out Z. Okay. Oh, I have it. Losing my mind. Set the variable. Now that should be first. Okay, so even though it's 111 here, when I print, once I call this, it's still back to what it was. Okay. So if I were to ask the question, think carefully. How many variables exist in this program? There's an X in main. There's a Y in main. There's an X in add. There's a Y in add. There's a Z that's outside of everything. And there's a Z in main. 6 different variables, okay? 6 different memory locations. You guys see that? Yes. What's that? Yes. They're being passed in here. Actually, this is still Y X, but you get the idea. So the X in here, because I can print X, so it must come from somewhere. The X is a separate variable. Okay. So to look at it as far as a picture of things here. So what am I doing? It's always a good question to ask yourself. Okay, so in this case, we have the main, we have the add. Okay. We started off setting Z in the global area, right? So Z is down here at 23. Okay. Then up here, we ran this, we had an X box and a Y box. Whatever those were, don't remember the numbers. We called add, we passed those. So we had, in fact, I had a Y and an X. Okay, so that goes to there. So that's a 10. That goes to there. That's a 12, but they're separate. Okay. And then main also created its own Z that had 20 or had 111 in it. Okay. So therefore we have 1, 2, 3, 4, 5, 6 variables. Okay. And again, lots of not good form there. So yeah, this especially is not good form. In general, you want to avoid global variables. They're just weird, they don't behave like you expect. Okay. But a good place to put global variables, let's say you have a tax rate. Okay. So the tax rate, we're going to make that a constant. Okay, so we're going to say tax rate equals 0.09. Okay. When I've set that there, I can now access it everywhere in my code, which is a good thing. Okay. So the only thing we're going to put in that area outside of the functions is going to be global constants. Okay. And again, Python should keep us from changing those constants, but it doesn't. It would just create a new version like it did with the Z. Okay. Questions on any of that stuff? There's some more in the spotlights if you want to go through some more examples of that. But the only thing that should be outside of that, in fact, you can often, it's often not a bad idea to put in like global constant section. And then we have our function definition section. Probably our call. When you do it this way, it doesn't matter what order you put the functions in, except you should only put main first. And typically, it's good form to put functions in the order that they're called. You don't have to, but it just makes sense when you're reading it. Okay, questions? Okay, let's move on to the last section today. We're starting with the idea of a value return function. Okay, so let's go back to sharing over here. When we define a function, we often are going to think of it as a black box. Let's say our add function that we did, add x and y. So we're going to have inputs into this function. And they could be any numbers at all. So this is going to be some, let's say it's 8 and 10, doesn't matter. Okay. Once we're inside the function, we can do whatever we want. Okay, we can do our sum is equal to, 8 plus 10, whatever. We can print from in here, but that's usually not a good idea. We can also have a value returning function, and we can return the 18. Okay. So we're not going to talk about how to do that today. We'll do that Friday. But we're going to look at some other things that we've done where we're using value returning functions. Okay. So we've already seen the print function. We've seen format is a better example. So again, format is going to take in what to print and the format string. Okay. And we'll output formatted text. So we've seen these before. So there's a lot of them built in. In fact, we've already used import random before, which is the next thing the book talks about. So just to say that whenever you're working in Python, there's going to be a library of functions it knows how to call. Okay. So things like print, input, range, format, lots of stuff, int, lots of things we've seen. These are all part of what we would call the standard library. In addition, Python has a massive free library system out there. Okay, some of those come with every installation of Python. The math library, the random library. Others don't. Others you have to download separately. Okay, but if we use import random, then what we're doing, we're adding to this list. Okay, we're going to have the rand int, which we used before, and some others. Okay. The reason they're not always available is we don't want to make our programs so big. So the ones that are included are the ones that almost all programs have. The others we have to add in. Okay. When we create our own functions, so we created our F1 or our add function, for example, that gets added in to the list of things that we can do. It's the things that your interpreter knows something about. Okay. So you'll often find the need to import things. Bunch of that stuff. That. Okay. So we've used the random numbers before in the craps game that we did for one of the labs. Okay. So remember that the first thing we have to do is import random. We'll see other libraries later. I'm not going to use any of that stuff. Okay. But if we want to generate numbers, okay, then what we've used before, we've done the number is equal to, we have to say random dot rand int, okay, because we want to make sure that we're getting the version of rand int from the random library. Okay. And with that, we're going to start with some minimum number, some maximum number. I can define those as global constants. Okay. So again, this function is a value returning function. So I have to put it to the right of an assignment statement. If I just did this, it wouldn't be wrong. So I did that twice today. I did mid. I'm losing my mind. That's weird to do it twice. I'll probably do it again 2 o'clock too. Okay, this doesn't do anything, right? Because I didn't save it. So this is going to produce an integer. So I can set number equal to that. And print out that number that I generated. Okay. If you're playing D&D, you probably died, right? You roll a 1, you were screwed. but these are random numbers. As I keep doing them, why am I getting the same number more than once? That's really weird. Now I'm getting it. Okay, so we're getting numbers. The rand int returns a number between, in this case, 1 and 20. Okay. So we can generate a bunch of numbers. We can have different ranges there. That's all okay. There's some other functions that we have that we can do in the random library that we can look at. There's a rand range function, and it works just like the rand, just like a range we do normally. So if I say rand range 10, it's going to return numbers. These are loops, we get a few of them. It's going to go 0 through 9. Okay, so there's a 0 to 9. Okay, we can do, if we wanted to do 1 to 10 specifically, I could do 1 to 11. We'll now do the 1 to 10. So the 0. What's the still the 0? Oh, so I did the wrong thing. Down here's all I want to change that. Change the wrong range. See, now they're all between 1 and 10. Okay. If I want to do something else, the third one here, the step is weird. What the step is going to do is it's going to only pick from every so many numbers. Okay, so if I wanted a step of 2, say I start at 2, go up to 11, it's going to give me only random or only even numbers. Sorry. See, they're all even. So that works just like our range does normally. There's also a random.random that's going, which works more like it does in C++. It's just going to return a decimal between 0 and 1. Okay, so with that, you can multiply it by things, you can do factorials or do mods on it, whatever you want to do. Okay. So those are the basic ideas that we have. So the next thing we need to talk about is just the nature of random numbers on computers. The way the random number generator works in Python, like in most languages, it's going to take something that's always changing, basically the system clock. Okay? It's going to perform some calculations on that to generate a sequence of numbers based on that seed we call it. Okay? You can set the seed directly in Python, and when you do, it always gives you the same list of numbers. Okay, so go back to the rand int here. I'm not really sure why you would do this, but you're trying to make a game that cheats. I don't know. But here, if I say random.seed anything for and I run this. So you get those numbers, 8, 10, 4, whatever. I'll run it again. I get the exact same numbers. Okay, so I've replaced what it normally would do would be to go out to the clock, get the time, make a random number based on that, to where it always goes to 4. Okay, that's always going to be the same sequence. Maybe for testing it makes sense. I'm not sure where else it makes sense. Okay, yes. The random seed, instead of going to the current time, because again, a computer can't pick a number, right? A computer can only do a formula based on something. So what it normally does, if you don't put a seed in, it takes the clock time, which is always different, and then generates random numbers based on it. Okay. When we tell it to use the seed 4, it's not using a random number. It's not using the time. It's using 4 every time. Okay, so the 4 is always 4. So when you apply the mathematical things to generate a string of numbers, then they're the same numbers every time. Okay. In fact, there is no way, programmatically, it's been proven mathematically, you can't generate truly random numbers with any program. It's not possible. The other way to do random numbers is to do something physical. Roll the dice, pick a card from my deck. Okay. This becomes a big deal in cryptography. And I assume you still can, you could for a long time, buy list of random numbers. The way they do those, I know that during World War II, they had two methods. One method for their cryptographic messages, they would take a deck of cards and have somebody all they would do, shuffle the cards, pull them out one at a time, and write down the order. That's a truly random event, and you can base things on that. The other one, there's a company that's been merged and everything else, but it's called RAND. If you've heard of it, RAND McNally, RAND this, RAND that. The RAND corporations, RAND is from random. And they invented, this is what started the company, this back in World War II. They invented a roulette wheel, electronic roulette wheel, that did nothing but spin itself and then write to a magnetic tape the results. So companies would buy, oh, I need 1 million random numbers. They would send you a file of 1 million random numbers, the really random numbers. Okay, so randomness is a complex issue mathematically. Okay, but for us, unless you put in the seed, you should be okay. You get enough to play games and all that. Okay, so if you're playing a game, it's never really truly random in a mathematical sense. It's pseudo-random, we would call it. Okay. Any questions? Okay, a couple homework problems out there. Make sure you get the problems from today done. They're due today, due as of 50 minutes ago. Okay. There are no other questions. That's all I've got. We'll finish up the chapter on what's that? It's on Moodle. I think it's 3 and 8 or 3 and 11. 3 and 8.